All right, in this video, we're going to do this AVL tree assignment. In this assignment, we're going to define a new class named MyBST, which extends the BST class. And we're going to add this method isAVL tree. And the book, if you're doing this assignment from the book, they give you this file here as a hint, which is this file, which helps you it includes the BST class, and it includes the code for testing your answer. You enter in a string of integers, from which it builds a binary search tree, and then it tests to see if the binary search tree is true. And it tests if it is in fact an AVL tree. And an AVL tree is a tree where the left child, the tree off the left, is an AVL tree, and the right subtree is also an AVL tree, and the difference in the height between the left subtree and the right subtree is no greater than 1. So that's the definition of an AVL tree. So this assignment is to modify the BST class, your MyBST class, which is an extension of the BST class, and MyBST class adds this isAVL tree method. All right, so let's start this, and the way I'm going to do that is I'm going to create a new, let me clean this out here. I'm going to create a new folder named AVL tree assignment, whatever. Okay, and I'm going to go in there. Here it is. Yes, can we send in? Here it is, and it's that's where it is. I'm going to copy that, and I'm going to open up a command prompt, and I'm going to do cd that. And so here I am in this AVL tree assignment, and then I'm going to do code space dot period to open up Visual Studio Code. And here we are, and I'm going to go back here and grab this code, all this code from the assignment. Shift click copy, and I'm going to do new file, and I'm going to name the file save as, I'm going to name it main.py, and I'm going to paste my code, and here it is. And I need to fill in this right here. And what comes with this code is the height test and the method which calls the actual guts of the isAVL tree method. And so in this isAVL tree 1 right here, we just need to test to make sure that the root that we're looking at is an AVL tree. And the way we do that is we test its left. First, we test to see if the left subtree is an AVL tree, and if it is, if we test the right subtree, if that's an AVL tree, and if it is, then we look at the height of each of the two left and right subtrees, and if they are the same height, they can differ by 1. If that's true, then the whole thing is an AVL tree. So let's take a look and see what the example is that we have here. And here we say we enter in this this sequence of integers here, and we determine that that's an AVL tree. So we actually can use the binary tree animation in section 19.2 of the Pearson book, and it defines a binary search tree, and it has this animation here where we can enter these digits in and see how the binary search tree is built. First of all, we have to remove this last node here. Okay, now the tree is empty. So now let's enter 60, insert, and then let's do 55, copy, paste, insert. Then let's do 45, I'm talking about this one, insert. And then let's do 100, insert. And then let's do 67, insert. And then let's do 87. And then let's do 107. And we see that is this an AVL tree? Well, as far as 60 is concerned, is the left side an AVL tree? Okay, it's 55. Is 55 an AVL tree? Well, the left child is the left child an AVL tree? Well, yes, it is. Okay, 45 is an AVL tree that it has no children, so it is. 55 is an AVL tree because the left child is a height of 1, the right child is a height of 0. 60 is 107 is an AVL tree. 67 is because its left child is height 0, its right child is height 1. 100 is okay. So this whole thing is an AVL tree. Okay, so it works. How about something like let's see. Let's delete this. Tell you what, I'm going to just simply remove 107. All right, is this an AVL tree? Well, no, it's not, because 100 is not an AVL tree. The left child, the height of the tree off the left side is height 2, 1, 2. The height of the tree on the right side is height 0. So that differs by more than 1. So if we test if this is an AVL tree, that should fail. So let's write this code. Okay, so here we are. So what does the code look like? Well, first of all, this is going to be a recursive method. So we're going to return if the self is AVL tree 1 of the left child, the tree off the left. If that is an AVL tree, if the left child is an AVL tree, and the right child is, if that's true, and the difference in the height, okay, well, I've got to add that in there. Okay, I've got to compute the height. I'm going to compute height 1 is equal to self.height, self.height, I'm going to name this something else. Height left. No, I'm going to name it this. Left height is self height 1 of root left. And I'm talking about this here. This returns the height. Do I want that to be? I guess so. This returns the height of the left tree. Yes, okay. And right height equals self height root right. Okay, now I can finish this one. I can say, and the I'm going to do absolute value function. Absolute value of the left height minus the right height. The absolute value is less than or equal to 1. It's either 0 or 1. Okay, so that takes care of the when either or both of the children are trees. But if this method gets called and the root is null, is non-existent, then we just want to return true because it is it's an AVL tree. Empty tree is an AVL tree. Its left and right children heights are the heights are the same. All right, this might be all that we need. Let's save this. And let's run it. Okay, now we have verified that this here is in fact the whole thing is in fact a, can I do this? I'm not going to do that. Paste. This whole thing is in fact an AVL tree. True. Oh, okay. All right. Problem is, it should be capital T. How do I end this? Ooh. Okay, so that was wrong. And is there any other ones? No, I gotta be it. Save. Okay, it went away. All right, I don't see any other squigglies. Oh, this is bad again. I get rid of that. Save this. Okay. Let's run this again. I'm going to click here. Run. Okay. Let me copy this whole thing, and when I paste it, it says it's an AVL tree. All right. Now, if I only go this far, just to 87, and I do not include the 107, I'm talking about this. No 107. I claim that this is not an AVL tree. So when I paste it here, when I run this again, run, and I paste everything but the 107, it's false. All right, very good. So the way I would hand this in is I would save it, save everything, I would exit. And what do I have here? I've got, here's my assignment. I would, well, I could send to compressed. And I end up with let's see, this thing. I don't need this anymore. But this is what I could hand in. So I go back to my assignment, and I go down here, and I would browse and find on my desktop this one, and submit this, and that would be it. All right, I hope that helped. Thanks for watching.